Hello again. So today we're looking at plotting and identifying cubic and reciprocal graphs. So the first thing we'll do is have a go at plotting both a cubic and a reciprocal, and then finally we'll look at identifying graph types. So on this first question here, we're asked to plot the graph y is equal to x cubed minus 3x minus 4. The first thing we need to do here is recognise the sort of graph this is. So in this case, our highest power is to the power of 3, and therefore we've got a cubic graph. All we do is we plot this for values of x. Now in this case we've been given a graph and we've got values of x that go from minus 3 all the way to 3, so we'll use those, and I've got the table ready over here. Now sometimes you don't get given the graph, nor do you get given the table, and if that happens I would suggest that you actually use values from minus 3 to 3. So now we're going to use the values minus 3, minus 2, minus 1. We're going to take them from there and we're going to substitute them into this equation here. Okay, so I've got the values of y just by substituting x into that equation. All I need to do now is plot the values of x and y. So minus 3 minus 17 is down here somewhere, and I'll plot the rest quite quickly. Okay, so they're plotted. Next thing is to draw a smooth curved line, just like we did with the quadratic. There we go, we've got a smooth curve going through all the points. All I need to do now is label this diagram, and I have done question 1, I've plotted that graph. Question 2, estimate the value of x when y is 6. So in this case we go to the value of y is 6 and we draw a line across until we actually hit the graph, and then we draw a perpendicular line down to the x-axis so we can see the value of x, and in this case here it looks like it's about 2.6. So we can say x is around about approximately equal to 2.6. Now before we go any further, I want to actually show you what a cubic graph will look like. So a cubic graph always has this kind of curve going on. It might be slightly flat like that, but it could also be the other way around, like so. So for cubics, you're looking for this style of graph. Whereas if you remember, a quadratic was a U or an N, and a linear is a straight line. Okay, let's move on to the next graph. So now we're going to look at plotting a reciprocal graph. So in a reciprocal comes in a different guise. So whereas with a quadratic we're looking for the highest power of x squared, for a cubic we're looking for the power of 3, but for a reciprocal what you're looking for here is y is equal to something k over x. So doing what we did before, all we do now is we find some values of x, and again in this case we've been given values of x from minus 6 to 6. I've got in my table minus 5 to 5. Again, if you haven't been given values of x, I would start at minus 3 and go to 3, and if you need to extend it beyond that, that's fine. So we're looking now for values of y, taking each value of x, substituting into that equation. Okay, so I've done the first ones. I've got when x is minus 5, I get y as minus 0.8, all the way down to when x is minus 1, I get y as minus 4. And hopefully you will recognise that we've got a 0 here. That means we're dividing by a 0, and we can't do that. We don't divide by 0. If you want to try it in your calculator, it won't let you do that. It'll give you a math error. So I'm going to put a line through that, and then I'll continue substituting those into that equation to get the rest of the values. Okay, so there are our values. All I need to do now is plot those. Okay, so I've plotted those. I want to show you what this graph looks like before we draw it on. So when we have a reciprocal graph, what happens is they never actually reach the axis. In this case, they tend towards the axis, but they don't quite ever reach that. In other words, what I'm trying to say is they don't come together. You can get cases where the graph might be shifted, but again, they don't come together. Okay, so plotting this now, what we need to do is imagine that goes towards the axis but never reaches it. So there we go, the graph is tending toward the axis but doesn't quite reach it. And the second part of the question here is just asking what is the value of y when x equals 0. Well, there is no value of y when x equals 0. What we can say is as x gets nearer to 0, the curve approaches the y-axis but never touches it. Our final part now is to identify graph types. Now the hope is that you've just finished doing the quadratic video and you've previously done the linear video. So you've got 4 graph types here. If you remember, a linear graph comes in the form y equals mx plus c, and that was a straight line graph. So for the linear one, we're looking for the straight line. Well, that one is this one here. So we can now look for the quadratic, and again, if you remember what I said, a quadratic comes in the form of y equals ax squared plus bx plus c. I said to you that is either an n or a u, and if you remember the quadratic ones, we have one turning point. So in this case, this one over here is the quadratic. That leaves us with the cubic. Now remembering what I said, the cubic has the highest power of x cubed. I mean, it can have bx squared plus cx plus d. It can be less than that. I'll just put the dots there to show the highest power is the cubed. So that one, if you remember what I said, was like this S, one way or the other, has two turning points. So we've got a pair of these here, if you look carefully. We have got one over here and we've got one over here. And finally, a reciprocal has this almost opposing pair of curves, kind of a back-to-back boomerang effect, never quite meeting. So that's your reciprocal. And that would be things like y is equal to k over x. And again, we've got two of those. We've got one here. And finally, we've got one over here. If you can sort of find your way to recognize these graphs, it makes drawing them so much easier. Now, if you know the shape of it, then you know whether you've got this right or wrong. As always, if you've got something from this, please like and subscribe. And my next video will be exploring exponential graphs.